In this video, we're going to have a look at the emerging technology of nanoscience. And nanoscience is all about studying objects and phenomena that happen at a very small scale, somewhere between 1 and 100 nanometers. And a nanometer is a billionth of a meter. That's incredibly small. And nanoscale science involves lots of different science disciplines working together. So physics, chemistry, biology, engineering, materials science, computer science, and others. So when we think about nano, look at this image of a human hand on the left-hand side. And if we keep zooming in and zooming in, we get to the nano level when we reach DNA and other molecules, including atoms. Not the atoms, molecules, but other molecules and the atoms which they are made up of. Those are all on the nanoscale. So hopefully you're a nanobit curious. Let's have a look at the sorts of things we can learn about the nature of matter, new theories we can develop, answer questions, and solve some problems in healthcare, energy, and technology, and essentially use this emerging technology to improve people's lives. So how do we see at the nano level? Well, we have to use an electron microscope, and that is because the electrons are small enough to resolve between 2 points that are nanometers apart. We can also manipulate at the nanoscale, so we can use microscopes called atomic force microscopes and scanning tunneling microscopes, and they can manipulate atoms to move around at the nano level. So we can see and we can manipulate at the nano level, but what can we make at the nano level? So we could make nanotubes, which are very strong and very flexible. We can make balls called Buckyballs. They are tiny nanospheres that maybe could be used to deliver drugs, and they're very non-reactive. They can move through the bloodstream very safely. And in fact, we can build and mimic the nano machines that already exist inside your cells and that are doing jobs right now as you sit there thinking. So let's have a look at the kinds of differences that you see at the nanoscale. When we get down to this tiny size, materials start to behave differently. So let's have a look at what kinds of differences we can see. Well, if we're going to look at differences, we might be thinking about optical differences, electrical differences, physical differences, and chemical differences. If we're thinking about macro things, like in this picture, the gold ring, a bulk gold ring, so just a gold ring on your finger, might look yellow, but when we get down to the nano level, because you're restricting how the particles move, how they interact with each other, because they are so thinly spread, and there's so few of them, you actually lose the gold color and they actually look red. So nano gold looks red. So we can change something's color. We can also change how things look, because normally if you take sunscreen with zinc oxide in it, it looks white because it's blocking all the light. But if we take nano-sized zinc oxide particles, their optical properties have changed, so they actually appear clear. And you probably have experienced some of the new sunscreens that are very high protection factor, but they spray on clear, and that's because they have nanoparticles in them. We can also use nanotubes to do conducting with electricity or semiconducting, and because they are flexible, we can put them into different situations. So let's see what we can actually do with these different properties and these different shapes, so the applications of nanoscience. We're going to look in the areas materials, healthcare, technology, and the environment. So in terms of materials, we can have stain-resistant clothes, and you think of all the advantages of this. We don't need to wash things as often. That's good for the environment. Materials might last longer. We could have paint that doesn't chip. So it's water and dirt repellent. It won't chip or scratch. The colours can be brighter and shinier. Maybe we could even think about having paints in the future that repair themselves. We could have paint that cleans the air. So nano paint could reduce pollution. You could have nano titanium dioxide particles, and they might break down organic and inorganic pollutants, so that then they can wash off in the rain. We could have nano solar cells, making them much cheaper and more energy efficient than some of the conventional solar cells. We could apply this to technology. Having a DVD that could hold 1 million movies. Imagine how much we would save from having to go to landfill if we could use a much smaller space to store much more information. We can also build smaller computer devices. We can lay down patterns atom by atom, using the atoms as our ink instead of ink as our ink. And we could start to integrate human nerve systems with computers so that we can have neurocomputation, we can have better prosthetics when you have to give somebody an artificial limb or something, and use biosensors to detect very small changes in our blood chemistry and interface with our nerve cells. We could detect, as I just said, diseases earlier. You can see we've got tumor detection in a little mouse here on the right. And we could perhaps repair tissue. So we've got nanofibers helping heart muscles to grow in the right way, just in the lab, but maybe soon in our own bodies. We've been very aware of vaccine development with COVID, so we might be able to use things like nano coatings on virus particles, and that could be an improvement in vaccine technology. And we could even send nano robots, or at least nano-sized delivery systems, into our body, maybe to break apart kidney stones or clean up the insides of our blood vessels or take drugs directly to tumor cells and kill them off. So all sorts of different applications, and these are only one or two ideas. So are there any disadvantages to this nanotechnology? Well, for a start, we have to consider that they are very delicate because they're tiny, they're atom-sized. So any radiation that strikes them could cause a complete destruction of the particle. So we'd have to be really careful if we're going to use this for something important that we have built in some backup systems. Okay, but in addition to that, we need to think about some potential risks of this new technology that we might not be aware of. So if you inhaled them into your lungs or swallowed them or absorbed them through your skin, they could be very damaging. Our body might react to them. You might try to fight them off. They could interfere with our white blood cells. They could upset any of the action of our enzymes in our body. In the environment, they could accumulate in the soil or the water or the plant or in plants. We could eat them because you can't just pass water with nanoparticles through a sieve because the holes are too big and nothing would catch them. I'm already aware of plastics that are supposed to be biodegradable, breaking down into nanoparticles and accumulating in fish or in filter feeders like mussels or oysters. So we know that this could be a potential problem. So we're going to need to think about the kind of risk assessments that are going to be needed and new laws and legislations that might be needed to regulate these nanoparticles. So in summary, we've got this awesome emerging technology involving lots of different areas of science coming together with the power to change the way that we interact with the materials in our world, but there are some challenges when it comes to thinking about long-term side effects and applications of these materials, but many applications really only limited by our imagination.